Welcome to multiple choice question 18 of the 2008 Mathematical Methods Exam 2. In this video we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. And now before we move on to the question, I'd just like to point out that the use of a CAS calculator is not really that appropriate for this question. So for question 18 we have let f be a function with a domain of 0 to pi on 2 where the rule for f of x is sine of 4x plus 1. The graph of f is transformed by a reflection in the x-axis followed by a dilation of factor 4 from the y-axis. The resulting graph is defined by one of the following options. So the first thing I'm going to do for this question is I'm going to use mapping to identify the rule. So if we take our coordinate x, y and we map that to a new coordinate which includes these transformations, if I first actually consider the dilation by a factor of 4 from the y-axis, that's going to result in 4 times x. Then the reflection in the x-axis is going to be negative y. So the next thing we do is we would say that x dash is equal to 4x and that y dash is equal to negative y. We now want to solve these for the non-dash term. So for the first one, I'm going to get x by itself by dividing by 4. So we get x is equal to x dash over 4. And for y dash equals negative y, that can just be rearranged so that y is equal to negative y dash. Next, we need to look back to our original rule, which is f of x equals sine of 4x plus 1. And wherever there's a y, or in this case f of x, we're going to put negative y dash. So we're going to have negative y dash is equal to, and then we're going to have sine of 4x, but instead of x, we're going to put x dash over 4 in its place, and then there's still going to be a plus 1 at the end of that rule. Next, we can see that the 4 being multiplied and then divided inside the sine function would cancel. And we can get rid of the negative in front of the y dash to get y by itself by multiplying all of the right hand side by negative 1. So therefore, g of x, because that's what all the options have in them, so g of x is going to equal negative sine of just x once the 4 and the divide by 4 have cancelled. And then importantly here, this negative also affects the positive 1 at the end to become negative 1. So we're looking for a rule that is negative sine of x subtract 1. So that's the same as negative 1 subtract sine of x. So that makes E the correct option. And one thing I will point out here is because of the dilation by a factor of 4 from the y-axis, our domain, which started out being 0 to pi on 2, does actually become 0 to 2 pi. And we'll explore that a little bit more on the next slide. So firstly, from the examiner's report, we can see that was a particularly challenging question for students, with only 36% of students getting that question correct, which is why I demonstrated using mapping, which is a nice robust way of getting the answer for that type of problem. It's possible that a number of students selected C because they were confused as to why the domain of the transformed graph had changed. And that's what I just want to unpack now with the help of an animation. So to unpack this idea a little bit more, I want to start with the graph of f of x. So that's the graph that's just been shown there. Next, what I want to do is I want to reflect that over the x-axis. So that's going to be this graph here now. And from there, we now want to dilate that by a factor of 4 from the y-axis. So the graph will end up at that point. And this will now be the graph of g of x. And now just to put a specific point on this graph for us to keep track of, let's have a think about the endpoint that occurred at pi on 2, 1 on f of x. After a reflection over the x-axis and a dilation by a factor of 4 from the y-axis, that point is now going to be at the point 2 pi, negative 1. So this is just going to show that not only has the graph rule changed, but also the domain. This is now going to go from 0 to 2 pi rather than 0 to pi on 2. So that explains why we've got that different domain in our answer to the one that we actually started with in the initial question. And the examiner goes on to make a particular note that the dilation by a factor of 4 from the y-axis will also affect the domain. So again, that was something that appeared to confuse students on this particular exam. So that's something that's worth noting down for yourself, that some transformations, not all of them, but certainly a dilation from the y-axis will affect a domain of a graph.